So today I would like to discuss a very important concept here. The first is rigid body. What is rigid body? Let's discuss first what is rigid body. So let's write a definition here. What is rigid body? So a rigid body. A rigid body is a rigid body. Body is a perfectly elastic, body is ideally perfect. It's ideally perfect, and it does not deform itself or change the displacement. Does not deform itself or change displacement by the application of force under the influence of the force or application of force. In real, such rigid body, such sort of rigid body does not exist. Such rigid body does not exist. Okay, so let's take an example to support what I have said. Let's take a marker for explaining it. So let's go. For a while, consider that this is something like this, something a rigid body. Rigid body is something like this. This is basically a rigid body, and another rigid body, something like this. Just like this. Okay. So now what I'm gonna do here is that look at what I'm gonna do. Just like the marker. Yeah, I'm taking that marker. First of all, what I'm gonna do is selecting the 2 points here. 1 point, but the other one point is there, and drawing a displacement along them, something like this. Displacement, which is 10. So let's write it as 10. And drawing another displacement, something like this. 10. For instance, consider that now I have applied force on this body of 10 Newton. For example, force is applied on this body of 10 Newton, and still it does not change its point of displacement. Like all the set of points on the displacement remains same. As you can see here, that the displacement is exactly equal, which is 10 meters, which means the rigid body is ideally perfect. It does not change or deform itself by the application of the force or to try to remain its displacement of all pairs of particles in force. Such body do not change. As you can see here, now real bodies, although are truly rigid, since the real body deform under the influence of the force. Right, but if the application of the force, for instance, let's consider the next case. Here, let's go back. Let's pause it a little more. Okay, let's move it here. So discuss the next part here. So let's take an example. Marker. This marker. Okay. Now I have applied a force, something like this. Then again a point, something like this. Something like this point. And again, but after the application of point, it changes displacement and deformed itself, something like this. Force is applied. So this is not a perfectly elastic body or not perfectly ideal body. It is not with the application, because with the application of force, it just changes deform itself or changes set of displacement in it. So like yeah, so this is not perfectly rigid body. If we talk about the type of rigid body, let's discuss the type of rigid body, type of motion rigid body has. Types of motion rigid body has. Types of motion rigid body has. Motion rigid body has. The first is translatory motion. Now what is translatory motion? Translatory motion. Let's discuss the first one, which is translatory motion. So for example, let's take two rotating pictures here, or one, the other one picture. So if these particles, like this body which is circular, this circular body is moving in a straight line. For example, this is a particle 1, particle 2, particle 3. Particle 1, particle 2 and particle 3. So it is trying to tell us that, it's just trying to explain us or just inform us about one thing. Just make it a perfect order like it. So let's do it. Okay, let's just draw it. Something like this, yeah. So what it's just trying to explain is that the when the different particle of a body move under the same displacement, which means in the forward direction, it is said to be translated displacement. That we can explain with the help of an example as well. For example, draw two parallel lines. For example, you have drawn a two parallel lines, something like this. Now this is the position of a body in a time t. Okay, this is the position of your body in time t, and this is the position of your body in time 1. For example, 1 second for a while consider it, right? This is the position of body in time 1 second. So let's take it 3 points. You can see here it's 3 points, then again 1 point, then again 2 point, here again 3 points. So let's draw, for example, if you draw a distance from here to here, something like this, then from here to here, you're drawing dotted line. First of all, consider dotted line, but I'm just making a complete line here. So as you can see, there is displacement. This is A, then A dash, then A dash, B, then B dash. Then we do the B dash. Then it's C, then it is C dash. As you can see that here, the A and A dash is equals to B and B dash. A and A dash is equals to B and B dash. A and A dash is equals to B and B dash is equals to C and C dash, which means the displacement of these bodies are equal, perfectly equal, right? So that what exactly trying to explain in this auto translatory motion, which means the parallel lines are drawn and the point are exactly equal.